my name is Michał, and in this presentation I will talk about Google Bug Bounty and my adventures with that program. I work at Securitum as a pen tester, which means I do security audits. And I'm mostly interested in client-side security, so everything that happens in the browsers, so mainly XSS issues. I was also in Google OXOA list of the best bug bounters, and here I provided some links to my blog, to Sekurak, the Polish service about IT security, and to my Twitter handle. I also lead a front-end security training in Polish, so if anyone's interested, then you are welcome. So the presentation will be divided into two main parts. The first one will be about organizational issues, so what's bug bounty all about, some statistics, how do you report a bug. Then I will answer some most frequently asked questions. And in the second, the main part, I will describe 3 findings I found in Google. Before I start, I have a request for you, because unfortunately I've got quite a huge hearing loss, so it might create problems with communication in the questions phase. So whenever you have a question, you can just go to the bentkowski.info/q page and ask the question there. The URL is in the upper left corner of the screen. So you can go here, ask the question or vote for the questions, and at the end of the presentation, I will check if there are any questions and answer the questions that are voted the most. OK, so let's start with the organizational stuff. What is bug bounty anyway? Because in the title of the presentation, it is called that it is about bug bounty, but what is? So it is basically a deal between companies and people who wish to test their security. And the deal goes like that, OK, you may test the security of our services. If you find any issue, report it to us, not to any third party, and we will pay you for it. And that's it. The most popular bug bounty programs are Google or Facebook, but there are huge amount of them. There are also 3 websites like Bugcrowd, HackerOne, and Cobalt, which contain, I don't know, maybe even over 100 bug bounty programs, so over 100 services that you are authorized to test their security. And if you find any issues, they will pay you. The Google Bug Bounty program is officially called Google Vulnerability Reward Program. And in their official site, you can find some basic information about the bug bounty. And here I pasted the table which shows you how much they pay for different class of bugs. As you can see, the amount depends on category of the bug and of the type of the application that you find the bug. So for example, because I will speak mostly about this kind of issues, the cross-site scripting issue in normal Google application, which is Google applications that do not process any sensitive data like translate Google.com or plus Google.com, you will get $3,000. For example, in accounts Google.com, which is the most important domain of Google, you will get at least $7,000 for an XSS, which is, I think, quite a good amount comparing it to the other bug bounty programs. So how do you submit a bug? There is a page at the URL goo.gl/vulns, in which you have a form when you can describe the basic information about the issue. So where did you find it? What is the issue anyway? And what is the attack scenario? If everything goes fine, after a few days, you will get a response from Google security team, which should go as that. I remember that when I reported my first security issue to Google, I thought that, wow, it is nice that they think that it is a nice catch, but they respond to this all the time. Only different persons are in this signature. And if Google decides that your issue is a valid security issue and they will pay you for it, after 2 weeks maybe, you will get the final answer that they thank you for reporting the issue. And as part of Google's vulnerability reward program, the panel has decided to issue a reward of and some amount of US dollars. And this process basically takes around 2 weeks. So it is really, really quick comparing to other bug bounty programs in which sometimes you might not get a response within, I don't know, 3 or 6 months. OK, so now I will go to frequently asked questions. How many bugs have I submitted? So it was 4 bugs in 2013, 6 in 2014, 10 in 2015, 4 in 2016, and none as far in 2017, because I didn't really have time to do this. With regard to type of the bugs, it was mainly XSS issues, 18 XSSs, and 1 of cross-site request forgery, cookie folding. It was a bug that worked only in Safari, with which you could set an arbitrary cookie in a mail.google.com domain. Clickjacking, outdated software, path traversal, but it was in a sandbox environment, so it didn't give me anything. And remote code execution, which was also in a highly sandboxed environment, so I really didn't achieve anything with that. But if anyone's curious, that was thanks to unserialization of data in Python with module pickle. OK, I don't know why, but many people ask me these questions. Do I report my bug bounty income to revenue service? And yes, the answer is, of course I do. I mean, I can't say I don't. Quite funnily, last year when I did a bank transfer because of the bug bounty income, the online banking system wrote a message that the transfer I'm trying to do looks a little shady, and I need to confirm it second time. I don't know why. So also, can you do a bug bounting for a living? And the truism is that it depends on your expectation, because for anyone, doing something for a living means something else. But the fact is that 1 XSS in google.com domain is $5,000, and after taxes in Poland, it is around 50,000 zlotys. So I don't know, 2 XSSs per month, and it looks pretty good. But the truth is that it is quite difficult to find many bugs in Google, because in 2014, I found only 6 bugs during the whole year, and they told me that I was in the top 10 of bug hunters that year. So for sure, you can do bug bounty for a living, but it might be quite risky. OK, now I will go to the technical part, and I will talk mainly about XSSs. So I will start with what is XSS anyway. So is there anyone that don't know what is XSS? Not many people want to admit. OK. This is a vulnerability which allows attackers to inject their own JavaScript into web pages. So you just can, I don't know, add a script tag and add some JavaScript. So the simple type of XSS is that, I don't know, you can write your name, and your name is reflected in the response somehow. But instead of your real name, you can add some HTML tag. So for example, if you add img, then suddenly an alert appears, which means the XSS executed. And usually, XSS examples are limited to alert 1. But what can you achieve with XSS in real life? Why Google pays $5,000 to alert 1? So basically, you can perform arbitrary actions in context of a logged user. It, of course, depends on what kind of application you found the XSS in. But you can do a bank transfer. You can add an admin user in the CMS. You can add a new plugin to a WordPress application, which make it possible to execute arbitrary code. You can change DNS configuration on your router if you have an XSS in there, etc., etc. Also, you can read arbitrary data in context of a logged user. So for example, you can read CSRF tokens, you can read bank account balance or contractors lists. If you have an XSS in Gmail, you can read all the emails. If you have XSS in Facebook, you can read the whole Facebook Messenger history or the list of friends. You can also attack the user himself or his network. So you can use a browser exploit to take over his computer, or you can perform a port scanning on his network, or even try to exploit known vulnerabilities in other components in the same network that the victim is in. And also, you can use victim computers to other purposes. For example, you can mine bitcoins, or I don't know, you can perform a DDoS attack. If you have XSS on, for example, 1 million users, then you can do a pretty effective DDoS attack if you decide to attack one specific website. Okay, now I will go to some examples of 3 examples of issues I reported to Google. And all of them are related to Caja. This is a JavaScript Sandbox that was done by Google. What is the concept of JavaScript Sandbox? Imagine that you have a website in which you want your users to insert their own JavaScript code. However, you don't want them to be able to access the DOM tree or to steal cookies or to perform requests in the same domain. So you want the JavaScript to be safe. And how can you do that? Well, you can do that with Caja. Oh, there's some Polish text in here, but here we have some, we can imagine that we have some trusted data here, and there is a box where is the untrusted user's code. And we don't want the untrusted user's code to access the trusted data. And we have Google Caja. And Google Caja is a tool for making third-party HTML, CSS, and JavaScript safe to embed in your website. So exactly what I described it right now. And Caja means box in Spanish. This is why it is pronounced Caja. We have some documentation on Google website, and we have a demo on caja.appspot.com. And let's have a look at the demo. It is quite simple. We have a big text area right here, in which we can insert some HTML code. Then we can press the Cajole button, and when we press it, we can see how Caja will process the HTML. So let's start with some simple example. Any HTML code we can insert here. There is nothing malicious here. There is no JavaScript here, so nothing will happen. But we can see just how this application works. So we pressed Cajole, and in the rendered results tab, we can see the output HTML. OK, so let's try with something more interesting and insert some alert. As usual, we tried alert 1 in the script tag. And the alert executed. However, we can see that the argument we passed to alert is prepended with the text untrusted code says. And this is what Caja did. Caja replaced the original alert function with their own alert function, and we can tell which one is it by the untrusted code says text. So when we see the untrusted code says, it is bad because we didn't escape the sandbox, but if we happen to do something to omit it, then it means that we did really great. OK, another example of XSS payload that is often done is alert document domain, because we want to know in context of what domain the JavaScript executes. So we press the Cajole, and we can see that there is some fake domain, no such host, that invalid. So Caja actually executes in some sandboxed fake domain. And let's try the last example. Let's say that we want to replace the body of the whole page with some text. In fact, there is a minor error in the code because it should set a window that top, that document, that body, that inner HTML, but it wouldn't change so much, so I just leave it as it is. And I press the Cajole, and well, nothing happens. So nothing should happen. OK, so let's try to dig in and check how Caja actually works. And we can do that with a very handy JavaScript keyword, that is debugger. When we say debugger and we have the developer tools in browser open, then there's automatically a breakpoint. So I have the debugger keyword, I open the developer tools, and then I click Cajole, and as we can see, we have the breakpoint. It says that it is paused in debugger, and then we can try to insert some code in the console. So let's see what happens. And we try to access the window object. It has some response. We will see later if it means anything. But let's try to do the alert. And when we do the alert, it might be quite surprising, but we don't see the untrusted code says text. The original alert executed. And it was kind of weird. It shouldn't happen. Why did it happen? So let's go back to the code and modify it a bit. And let's say window alert 1, and then use the keyword debugger. And when we do that and press the Cajole again, we see that we have the untrusted code says, so the sandboxed alert. However, when we go back to the console, we can see that when we say window now, we don't have the window response, but tame window. And in fact, it seems that Caja actually looks for tokens in the JavaScript code and deletes all the tokens it finds from the global namespace. So in the last code, we didn't have the window word in the code, and it didn't do anything. However, when I said window alert 1 and then debugger, then the window is a fake object. It is not the real window object. OK, so now let's go to some advanced maths. Everyone knows that there is an eval function in JavaScript and some other programming languages. However, in JavaScript, we can also use the function constructor. And it is quite important because in Caja, the eval function didn't exist. However, the function constructor existed. So we create a function whose body is equal to the string we pass. So we can return the 2 plus 2, and then we can execute the function. And my idea was that if Caja looks for some tokens in code, so instead of writing return window, we can say return win plus do. So there's no window word in the code, so maybe it will help us to bypass Caja. So let's try it. I go back to the code using the wind plus O trick and try to alert something. And it didn't work. It seems that Caja uses its code to find tokens in every sync of JavaScript code it can find. So in the script tag, in the evals, function constructor, and all of the places that accept the JavaScript code. So it wasn't that simple. But there's also another thing. Let's say that we have some string in JavaScript. And any letter we can write as the letter itself, or we can use the Unicode escape. This is in every programming language to escape from some characters. So we can do the same, for example, with the window word. We can have a string window, and we can have a string u0077 indo. However, in JavaScript, we can do this not only in strings, but also in the code itself. So we can say window, and we can say u0077 indo in the code. And it is exactly the same. And as you can see, we have another representation of the window token. We can just compare if the u0077 window is in fact the same as the window, and as we can see, it is true. So let's go back to the Caja, and let's write u0077 indo.alert1. And when I press Cajole right now, we can see that we have alert1 without the untrusted code says. So we actually escaped the Caja sandbox. And let's try another example with the alert document domain. I will reference the top window and eval alert document domain in it. And when I say Cajole, we can see that I work in the domain caja.appspot.com, which means I am in the main domain I shouldn't be able to escape to. And as a final example, let's try to replace the inner HTML of the main element with the underlined text hacked. And when I say kahole, you can see that the entire body disappeared, which means I escaped the box I shouldn't be able to escape. So in Google Docs, Kaha was used to sandbox the app script user can write. So thanks to this trick, I had an XSS in docs.google.com domain. So Kaha looked for tokens in JavaScript code and deleted them from global namespace. The bypass was that the window can be written also as U0077 window. 2 weeks passed by, Google fixed the vulnerability, and the token searcher keeps in mind that U0077 window is equals to window. But is it enough? And does any of you worked with the ECMAScript 6 or ECMAScript 2015 standard? Not many people. Well, ECMAScript 6 added a new Unicode escapes. So instead of U0077 window, we can say U curly braces 77. And you may ask why. What was wrong with the first option? Well, probably emoji was the cause. Because let's say that we write 2 Unicode escapes like that, and we get the happy emoji in the string. So it looks like there are 1, 2 characters, but we in fact get only 1 character. With the new type of escape, we can clearly see that it is actually just 1 character. So this is probably the reason why it was introduced. So let's go back to the Kaha. And will it be that simple? U curly braces 77 window that alert 1. Let's try it. I say kahole, and well, nothing happens. Let's go to the compiler messages, or runtime messages, I don't remember, the runtime messages tab. And we can see that we have a syntax error here. And it turned out that Kaha has their own JavaScript parser. The JavaScript parser written in JavaScript, by the way. And it was called Acorn, and the Acorn JavaScript parser worked in ECMAScript 5 standard. So it didn't know the new type of escape sequence. OK, so how can we bypass it? Let's see what kind of comments we can have in JavaScript. How many type of comments we have in JavaScript? We can see 2 of them here. And does anyone know of any other method of commenting in JavaScript? There are 2 types of comments that looks like HTML comments. This less than exclamation mark minus minus comment is a line comment. It ends at the end of the line. Another comment in JavaScript is the close of HTML comment, which is also a line comment. However, it works only if before this sequence is only white characters, so spaces, tabs, etc. And let's have a look at the source code of the Acorn parser. As we can see, the parser knows about the XML style comments. And it sees that there is this type of comment, increases the position of the token by 4, and then goes to the function skip line comment. So let's have a look at the function skip line comment. And as we can see, there is a really minor mistake here, because the token position is incremented by 2 again. It was incremented by 4 earlier, but now it is incremented by 2. And this is a mistake, because it means that the 2 characters that are directly after the opening of the comment are ignored. So when I have a new line just after the opening of the comment, the parser will think that the whole next line is a comment. Let's have a look. We go back to the code, and we add an empty comment here. It shouldn't change absolutely anything, because, well, this is a line comment, so it ends here. However, the parser thinks that the whole next line is also a comment, so I will have no syntax error again. And I say kahole, and I have the alert. Second bypass of Kaha Sandbox, and it was actually a second distinct bounty for me. And let's go back with the alert document domain example. So I have, again, U77 in the top evil other document domain. Well, and it just works. So ECMAScript 2015 introduced a new type of Unicode escape, U and 77 in curly braces. And there was also an error in Acorn, the JavaScript parser that Kaha used, which could be abused with a comment. OK, so another few weeks passed. Google updated Kaha, but not everywhere. They have some examples of Kaha in their own domain, developers.google.com. And that was one interesting demo. We have a very simple page in which we can pass a URL, which will be executed using Kaha. So I can say data URL here, and just use the same code I used before. Use 0077 in the top eval other document domain. And then I press set, and as you can see, I have the XSS in developers.google.com. However, the problem here is that the user has to enter the code himself. So it is quite unlikely attack scenario that when you have to convince the user to enter JavaScript code himself, then why don't you just tell him to open the developer tools in your browser and type it there? So I needed something to make it more likely that the user will execute that XSS. And it was possible thanks to drag and drop in HTML5. Here is a quick lesson. We have a div element, which is set that is draggable, and we have a function drag, which is executed when user starts dragging. And as we can see, we can say some text here to the drag event. So let's see how it looks. User drag and drops, and the text is pasted. So instead of that dowolny text, we can say U0077 in the top alert 1. And then user might do a drag and drop. And the XSS payload will paste here. So how the final exploit looked like. We can imagine that that would be some kind of a game for the user, a game that tells him that to win money or, I don't know, women, he needs to drag that red block to the blue block and then press the green block. And let's see what happens. He drags it, drops it, press the button, and magically an XSS executes in developers.google.com domain. What happened here? Well, actually, there was an invisible iframe. And when user thought that he is dragging some boxes, he actually dragged the boxes on that iframe. So let's see, when he drags the red box, he actually dropped the XSS payload into the formula URL. And when he pressed that green block, he pressed the set button. So thanks to the drag and drop in Firefox, because this attack was only in Firefox, because other browsers don't make it possible to do a drag and drop across different origins. So only in Firefox. However, Google had a problem that they forgot to update Kaha in all instances. And thanks to the drag and drop abuse in the Firefox, we can exploit the XSS with, well, quite likely user interaction. OK, so to summarize, the Kaha sandbox escapes have given me 3 distinct bounties from Google. And all I had to do was to use alternative means of token representation, U0077 Indo or U in 77 in curly braces. And then I used the drag and drop in Firefox thanks to Google's forgetfulness. They forgot to update Kaha in all instances. OK, to summarize, Bug Bounty was quite fun and profit for me. The Google's Bug Bounty program has a really good communication. The responses are usually automatically generated. However, they are pretty quick, which is, I think, the most important thing. And bug hunting requires some luck when you look for some bugs. However, the more you know about HTML, about JavaScript, about browsers, the more likely you are able to find a bug. Okay, that's it.